related to irrigation efficiencies. So first we should know what is irrigation efficiency. So efficiency is the ratio of the water output to the water input, and it is usually expressed as percentage. So input minus output is nothing but losses, and hence if losses are more and output is less, and therefore efficiency is less. Hence efficiency is inversely proportional to the losses. Water is lost in irrigation during various processes, and therefore there are different kinds of irrigation efficiencies which are discussed in our next slides. The first one is efficiency of water conveyance. So it is the ratio of the water delivered into the fields from the outlet point of the channel to the water entering into the channel at its starting point. It may be represented by efficiency suffix C. C stands for water conveyance. It takes the conveyance or transit losses into consideration. Number 2 is efficiency of water application. It is the ratio of the quantity of water stored into the root zone of the crops to the quantity of water actually delivered into the field. It may be represented by efficiency suffix A. A stands for water application. So it may also be called an on-farm efficiency as it takes into consideration the water lost in the farm. Number 3 is efficiency of water storage. It is the ratio of the water stored in the root zone during irrigation to the water needed in the root zone prior to irrigation, that is, fill capacity existing moisture content. It may be represented as efficiency suffix small s. S represents water storage. Next, number 4 is efficiency of water use. It is the ratio of the water beneficially used, including leaching water, to the quantity of water delivered. It may be represented as efficiency U. U suffix U. U represents water use. Number 5 is uniformity coefficient or water distribution efficiency, and it is important. So just go through it. The effectiveness of irrigation may also be measured by its water distribution efficiency, which is denoted by efficiency suffix small d. D represents water distribution, which is defined below. So water distribution efficiency is equal to 1 minus average of the absolute values of deviations from the mean divided by mean depth of water stored during irrigation. The water distribution efficiency represents the extent to which the water has penetrated to a uniform depth throughout the field. So when the water has penetrated uniformly throughout the field, the deviation from the mean depth is 0 and water distribution efficiency is 1.0. So the next numerical is 1 cubic of water is pumped into a farm distribution system. 0.8 cubic is delivered to a turnout. 0.9 kilometer from the well. So you have to compute the conveyance efficiency. So as per the definition of conveyance efficiency, this is equal to output by input into 100. So the output was given as 0.8 and the input was given as 1.0. Multiplied by 100 is equal to 80%. 1.0 because of 1 cubic of water. The next numerical is the depths of penetrations along the length of a border strip at points 30 meters apart were probed. Probed means placed. So the observed values were 2.0, 1.9, 1.8, 1.6 and 1.5 meters. So compute the water distribution efficiency. We have to find out the water distribution efficiency. So the solution is the observed depths at 5 stations, which is already given, are 2.0, 1.9, 1.8, 1.6 and 1.5 meters respectively. So we have to find the mean depth now. So mean depth, that is capital D, is equal to 2.0 plus 1.9 plus 1.5 plus 1.6 plus 1.5 divided by 5. So the answer comes out to be 1.776 meters. So now the values of the deviations from the mean that we found are 2.0, which is the observed depth, minus the mean depth, which is 1.76. Similarly, observed depth 1.9 minus mean depth 1.76. Then 1.8 minus 1.76, 1.6 minus 1.76, 1.5 minus 1.76, and by subtracting these values we found the answers as 0.24, 0.14, 0.04, minus 0.16 and minus 0.26. So the absolute values of these deviations from the mean are again 0.24, 0.14, 0.04, 0.16 and 0.26. Now we have to find the average of these absolute values of deviations from the mean, which is small d. That is 0.24 plus 0.14 plus 0.04 plus 0.16 plus 0.26 divided by 5. By calculating, we found the answer is 0.168 meters. So now, the water distribution efficiency, whose formula is 1 minus small d by capital D, is equal to 1 minus mean. Mean we found out as 0.168 meters, and capital D is found out to be 1.76 meters. So by computing, we found the answer is 0.905. And the water distribution efficiency is found to be 0.905. So this is your assignment for lecture number 11. The question is, you have to name the principal kharif crops of your region and detail the agricultural and climatic requirements for sowing, growth and harvesting of one or more of the principal ones. So you have to give the normal requirement of seed per hectare and the average yield per hectare of the crop. You also need to suggest ways to increase the duty in an irrigation system. Of your region means the place or the area where you are staying maybe. So you can do a short, or you can give a short detail on that. The last date of submission is on or before 18th of September. I will go through a video. It might be long, a slight long video, but it is informative, so you can look through it. That's all.
Peterson here from Glenville, and he's been working with NRCS for a few years now on one of the most recent ones, which is a pipeline project with the idea of saving some water. We used to have a ditch running parallel with this road, and actually the ditch used to be right where the road is, and then the ditch at 90 and go across and then water this way. Well, now we just have one solid pipeline, a 21-inch and 24-inch pipe, and put these risers and eliminated a lot of ditch, and we're getting pretty good flow out of it. And we used to take, I don't know, probably 7 days to water this whole farm, and it's taken us about 4 days now. And that's what's so nice about the system. If one side of the field's ahead of the other, you just close one down and hope for one, or either or, and it's just as simple as this. So it's pretty good to regulate. I guess what excites me the most about it is seeing the amount of water that we can save doing a project like this. This is the first crop in after we put the pipeline in, and we dissed it once, and then had him come and level it, and he put a nice finish on it, and then we just left it alone and come in here.
So it'll be fun to see how this irrigates with it being level, as opposed to still, the field we were just looking at that you're going to do a touch-up on later.
One of the first projects I did with the NRCS was this pivot. They got me started. We did an Arnold loan on it, and Arnold helped me with the pipeline. We got it piped out here, and what this pivot's done to my farming operation is increased me just tremendously. I mean, the production of this hay, and you can see how productive this hay is. It's been a great asset to this farm.
So this is Neil Clayton, and come out to visit with Neil and talk about this ditch project that he put in here. It's been a few years, hasn't it?
This will be the fourth year.
Fourth year. So you've got some experience with it.
Well, you have to love cement ditches. Obviously, the less time. The water savings tremendous. We went from an 8-foot stream to a 10 to 12-foot stream. So basically, we got from on a 40-acre piece, roughly 32 hours down to 24 each irrigation, which is tremendous. Pretty simple, just close it, drop it down, makes it pretty easy. You have the same type of gate in the middle, one gate to open, one gate to close. The water savings there, the time irrigating's there. Obviously a lot better, easier to maintain, keep it clean. It doesn't take a lot of water. I mean, it really don't. The head pressure we get here is phenomenal. But this ditch, I mean, it's crazy. It just gets you enough to get on. You can push it. Which I'd rather water fast twice as once and soak it, and not have it just go into the substrate.
So that's how you're getting your efficiencies.
Push quicker. The hay isn't staying just in Utah. It's going everywhere worldwide. So yeah, I think it's really crucial that we take care of things and do them right.
You've got to be on the production end of it. You've got to have all of this has got to be in the computer. You've got to see where you're marking.
Yeah.
Well, that's what my boy's doing that I never did. And he's different.
He's been amazing. I walked out and he showed me just his records.
Also, all the fertilizer he put on, he knows how much seed he's got to plant, get maximum yield. He keeps track. He's got records back of every stream of water he ever took and how long that keeps doing. And that's the winter. Yeah. That's how you make the money. If you aren't doing that, you won't back it up to go home. This is make this a beautiful valley.
It is
Look at the valley. The fences are clean. The ditches are clean. It's just a nice valley.
I hope you enjoyed meeting Neil and Chad today. This is what makes my work so enjoyable, is to see them have some success at accomplishing their goals on their place.